In this video, we're going to look at another example of finding the limit of a function of two variables. So we're being asked to find the limit, or show that it doesn't exist, of the function y minus x all over 1 minus y plus natural log of x as xy approaches the point 1, 1. We notice that we cannot evaluate this limit by direct substitution, because if we try to plug in the point 1, 1, we end up with a 0 in the denominator. However, we also notice that if we put the point 1, 1 in the numerator, we also get 0, so we end up getting 0 over 0, which tells us that we need to do more work in order to be able to figure out what this limit might be, or that it may not exist. So one way to show that a limit doesn't exist, which is what's going to be the case in this particular problem, is to choose two different paths that go into the point that you're interested in, and show that you get two different answers for your limit. So one way to get closer and closer to the point 1, 1 would be to follow the line x equals 1. Make your x coordinate always equal to 1, and make your y coordinate get really, really close to 1. If we do that, we can replace all the x's with 1's, and then we still have the limit as y approaches 1, and we end up with y minus 1 over 1 minus y. That cancels out to be negative 1, and certainly the limit of negative 1 is just negative 1. So that we conclude that along the line x equal to 1, this limit turns out to be negative 1. What if we choose a different path? Say we look at the line y equals x. Well, if we replace the y with x, on top I get x minus x, which just simplifies to 0. Now we get the limit of x approaches 1 as 0. That's just 0. Okay, so let's recap. Along the line x equal to 1, we got negative 1 for our limit. And along the line y equals x, we got 0 for our limit. But we can't get two different answers for the limit and have the limit exist. So we conclude that the limit does not exist. This picture isn't the greatest, but let's see what we've got going on here. So the red axis is the x-axis. So this black line is illustrating coming into the point 1, 1, which is about right here where all this mess, you can kind of see this mess going on here. The computer graphics that we're trying to generate here are having issues with that getting really, really small in the denominator. It's having issues there. That's why it looks all crazy. But if we go along the line x equal to 1, we notice that that surface, you can kind of see it there in the background. You can kind of see it here in the foreground. It's always equal to negative 1. Here's the negative 1 coordinate for the z. So we really do see that the limit really is negative 1. Versus, if we go along the line y equals x, well, over here I don't have any surface, but I do have it over here. If I go along the line y equals x, and I get closer and closer to the point 1, 1, but notice that the function's always equal to 0 at that point. I see that line's intersecting that surface there. So we're really getting two different answers for the same limit. Well, that just tells us that the limit can't exist because we're not allowing two different answers for the same limit.